All right, welcome back everyone. And in today's lesson, we are going to take a look at trying to find the measure of the interior angles of any polygon. And we are going to use some of our previous knowledge, some of our previous lessons from this week and from last week to help us to understand what we are actually doing here. So if you look at the title of this lesson, it does say divide any polygon into triangles. So clearly the work that we did with triangles earlier this year is going to be huge here. And hopefully we all remember that the interior angles of any triangle will always equal 180 degrees. And that's going to be the key for us as we move forward through this process. The key is to identify how many triangles actually appear in each of these shapes. We should also already know that the interior angle of all quadrilaterals is 360 degrees. And hopefully we were able to prove that by showing you how many triangles can be created inside of a quadrilateral. And that is the first question that we are going to attempt in this lesson right here. As we see this very irregular shaped quadrilateral here, but we can definitely see the number of sides as 1, 2, 3, and 4. So this is clearly a quadrilateral. It is a four-sided figure. And to determine how many triangles there are inside of here, we pick a corner. Looks like they're highlighting this one for us to start with. And from that point, we need to draw a line across or create what we call a diagonal, which means that we need to draw a line across and divide this shape up by connecting its corners. Well, I can't draw a line going this way to divide it because that is simply an outside line that we are using for that quadrilateral. So in this case, the only line I can draw is the line that goes directly across this shape. Now, those triangles are not even. We're not saying that we are dividing this shape up into even triangles. If it was a regularly shaped object, we could, but in this case, it's not a regular quadrilateral. It is just an irregular quadrilateral. So to answer this question for number 12a, it says how many sides does it have? We've already counted. We see that there are 4 sides on this shape, on this polygon. And we have drawn one diagonal going across, and that has divided this piece, this quadrilateral, up into 2 triangles. So I want you to really take a look at that relationship of those numbers as we move forward through this process, because there will be questions eventually that talk about you having to imagine a 10-sided figure, a 12-sided figure, and being able to determine how many triangles are inside of it. That will be part of the process here. So just be aware of that. We are showing you a pretty easy thing right now because we're drawing the pictures, but eventually we won't have these pictures, or you should be able to figure out what these triangles and how many triangles will be inside these shapes just by the pattern that we are establishing here. So as we look at shape B, we see 1, 2, 3, 4, and 5 shapes. So we have a pentagon here, 5 sides, but it is a 5-sided figure, which means it is a pentagon. And in that case, guys, it is not, again, a regular pentagon. So we need to, and are not going to divide up into equal triangles. We are simply going to see how many triangles in general we can create here. So again, starting from that point, it doesn't matter which point you start from, but they're giving us a starting point there. I start to draw diagonals across from corner to corner. There is one triangle that I've created, and I can draw down here and create a second triangle. And those are the other line that I can draw there, which gets me to a total of 3 triangles. So now I'm looking here at these relationships for the first 2 that I've created, and I can see that a 4-sided figure, if I use diagonals, can create 2 triangles, and a 5-sided figure can create 3 triangles. So again, keep that in mind as we are progressing through here. Hopefully that will start to stick with you as we move forward, or we'll see a formula that can be created. All right, the next shape we are looking at here, we'll count the sides, 1, 2, 3, 4, 5, and 6. So this is a 6-sided figure. We call those hexagons. Again, this one looks to be a little bit more regular, but not quite a perfectly regular hexagon, but a little bit closer than our other 2 shapes. So now again, I'm going to start at the highlighted dot, or the dot that they are giving us to start from, and start making diagonals. To that corner would be 1, to that corner would be 2, and to that corner would be 3 lines. Now, how many triangles have I created in that situation? There's 1 triangle, there's 2 triangles, 3 triangles, and 4 triangles in that hexagon. So again, hopefully now three of our problems into this, you should start establishing and recognizing these patterns. All right. And the last one of these image problems that we have, the pictures or the problems with the pictures, to help us with this process, we see a 1, 2, 3, 4, 5, 6, and a 7-sided figure called a heptagon. And again, as I draw these diagonals going across, 1, 2, 3, and 4, but we're not counting diagonals, we're counting triangles. 1, 2, 3, 4, and 5. So again, 2 less than the number of sides. And guys, if you haven't figured it out yet at this point, that is the formula that we will use to determine how many triangles can be created inside of a polygon. The number of sides minus 2. Clearly, a triangle itself is what it is. It's a 3-sided figure, and you can't do any diagonals inside of it, so that is 180 degrees. If we look at the quadrilateral, however, go back up here to our quadrilateral, we can see that we've created 2 triangles. So imagine that each of those triangles has a measure of 180 degrees of angles inside of them, and now we have 2 triangles. We add those 2 180s together, and we end up with 360 degrees. And so that again is what we need to do. We need to establish how many 180 degree figures can we create inside these polygons, and that will then give us our total, and we can divvy up and figure out hopefully either the total of the angles or the missing angle, whatever the question is asking us for. So question 13 says, how does the number of sides compare to the number of triangles? Okay, so in this case, the number of sides is 2 more than the number of triangles. Running out of space here. Okay, so it's always going to be the number, n, of sides minus 2, and that will get you how many triangles you will find in that situation. So here is that first question they ask us. We can draw the picture of an 8-sided figure. It says, how many triangles do you think will be formed in a polygon with 8 sides? So again, like I said, you can take the time to draw an octagon. You can take the time to draw an 8-sided figure, but I'm hoping that you don't have to do that. Okay, we have an 8-sided figure. We've said that our formula is 8 minus 2. There should be 6 triangles created inside of that polygon. All right. And then it says write an expression to show how many triangles will be formed with a polygon with n sides. So again, n is our variable, minus our 2 will equal, and again, it's an expression, so I should have stopped right there, but I'm going to write the equation piece of it. N minus 2 equals the number of triangles created. All right, so that is the first part of our lesson for today. We will continue on to the next page and talk about, actually, going to scroll all the way down here. Maybe. Oh, it looks like we got a second page here on this one. This is the page I really want to get to here. Again, I want you to establish the pattern, and then I want you to, more importantly, find the sum of the interior angles. Remember, sum right here is the total, the added up total of the angles. Okay, so we are going to add them all up, and again, we said this is based upon the number of triangles you create, the number of 180 degree angle shapes you have created inside there. So let's first establish how many triangles are formed from each of these polygons. So you can see the relationship. 4 minus 2 gets us to 2. 5 minus 2 gets us to 3. So the same thing here. 6 minus 2 gets us to 4, 7 minus 2 gets us to 5, and 8 minus 2 gets us to 6. Now I showed you on the last page in the beginning part of this lesson that we then can look at this and say if those are the number of triangles and every triangle we know has a total of 180 degrees in angles, we can then multiply that number or add that number that many times to 180. All right, so 2 times 180, or 180 plus 180, I showed you before that all quadrilaterals will have a 360 degree total angle, interior angle, a sum of the interior angles of 360. All right, so if we look at a pentagon, we are going to either add 180 3 times, or we are going to multiply 180 by 3. I probably should have put it on top just to make this math a little easier for me, but I think I know this one off the top of my head anyway. It should be 540 degrees of interior angles inside of a pentagon. If we have a hexagon, 180 degrees per the 4 triangles, and we come through here and we end up with 720 degrees of interior angles inside of a hexagon. Same thing for the next one, times 5 gets us to 900 degrees of interior angles. And the last one here, again, all based on our knowledge of triangles equaling 180 degrees, and we've created 6 triangles. So 6 times 0 is still 6. 6 times 8 is 48, carry the 4, and so we are at 1080 degrees for the sum of the interior angles of that polygon. Now, as we move forward here again, guys, we should be able to determine and figure out if they give us 3 or 4 or 5 sides, how many the missing angles would be by taking it away from the sum of those interior angles. Thank you very much, guys. Have a great day, and please answer the questions that are following this video.